Let's see, they'll pop up here. All right, is that working now? You got sound now? Just let me know if I got sound. There you go. Okay, cool. All right. So yeah, I made the capacitor. So let me just go again. So I made my homemade capacitor. So I went to Staples and I grabbed those laminate plastic sheets that you use for like dividers, and I cut it and made it about 8.5 by 11. And then I put one plastic sheet down. Then I cut aluminum foil, leaving an edge so the aluminum foil doesn't go all the way to the end. So you're going to leave a little space around that sheet. So I do aluminum foil, then I put a plastic sheet, glue it in so it's nice and flat, no air bubbles, nothing. Make it perfectly flat. And then put another layer of aluminum foil. Okay, so the first aluminum foil that you lay down, you're going to put out one wire. Okay, and then the second aluminum foil, there's no wire. And then the last layer, you're going to put the last wire. So you're going to have plastic sheet, aluminum foil, plastic sheet, aluminum foil, plastic sheet, and then wire, and then that it's pretty much done after that. And then all you have to do is roll it up and then tape it nicely. And I hooked this up to my Don Smith generator last night, did some tests with it. So I put 11,000 volts through this, and she worked fine. It didn't arc, it didn't smoke. So I think what's really important when you do these homemade capacitors, I used a glue stick, one of those Elmer's glue sticks, you know, the ones you have for kids. I put that glue on the plastic sheet, and then you put the aluminum foil on it and smoothen it out. There cannot be any air bubbles. It has to be perfectly flat and secured. And you do that 3 times, and then on the end ones, the first one and last layer, you have to attach the wire to it. All right. Now you could tape it down, you could glue it down, you could, well, you can't really solder it, but I basically taped it down with electrical tape, and then I put a little bit of glue on top of it just to secure it so it won't come out. And yeah, so it's 3 layers, 8.5 by 11 sheets. You can pick up those laminate sheets at Staples, so you can pick those up. And yeah, make your own homemade capacitor. So I got that done. So tonight what I'm doing with the plasma ball, I got it right here, I'm building a collector plate. So I was actually looking on Google on antenna designs, and this one here is actually made for receiving 5G, but I figure this might actually be a pretty damn good design for actually collecting the radiant energy that's coming off the plasma ball. So I'm just doing a kind of a test rig here. I literally taped these 2 coils are 1 inch diameter by 3 inches tall. All right, and yeah, if you like my video, in my other video descriptions, I got a PayPal donate if you like what I'm doing tonight. Chip me $1, you know, to buy a coffee, right? Keep me going, keep me doing the experiments, right? So yeah, I do want to mention too, there's another friend of mine I want you guys to check out. In my last video, in my video description, I have him. His name is Paul. He's out of Chicago, and he calls himself Inventor 3. Some of you guys might already know him. Check him out. He's awesome. Like, his videos are so good, and he's got a lab set outside in a tent, and he does Tesla stuff. He's doing wireless transfer of power right now. The guy's amazing, amazing. So check him out for sure. And I got his link there, or you could do the search on him. He's called Inventor 3. And check out Paul. I really like what he's doing. He's really cool. He's even mentioned my channel on his YouTube channel, so that's awesome. You know, I'll give back the love any way I can. So yeah, let's carry on. So I got the plate. What I also did with the aluminum plate, after a while it tarnishes. So I got the emery here, the Scotch-Brite, and I sanded it down to get a good finish on it, get the tarnish off, so I get better conductivity. Okay, so I got that done. I'm just trying this out. I don't even know if it's gonna work yet. So, and I'm just gonna. The only capacitor I'm gonna hook up to it is this. Um, okay, so what I'm gonna do is I'm gonna hook up this capacitor. So I'm gonna hook it up on this side here. Now, what I'm gonna do, I'm gonna do it two ways. I'm gonna hook up the first lead for the capacitor. I'm gonna try it once off the spring, and then the second time I'm gonna do it, it's gonna be off the plate. So I'm gonna try both ways to connect the capacitor. So I think the first way I'm gonna do it, I'm going to do it off the spring. One connection off the spring. Let's see how I'm gonna do this. Now this is just a quick mock-up, everybody, so this is not like in stone what I'm doing here. I'll try to fold it around. I'm gonna do this. So I've been kind of researching on 5G antennas, and I've been studying a lot of Dollard stuff lately. If you like what I'm doing right now, give me a thumbs up. That'd be great. So I'm just folding this in. Okay, that's dead. Okay, that's good. All right, so I've got that connected. I'm going to raise this plate off the table. Just put the tape on it because I want to kind of isolate it. All right, so it's going to radiant energy. It's going to hit the plate. From there, it's going to go to my capacitor, come out of my capacitor, and then it's going to go to the light. So what I'm going to do is start hooking up my light. Now, one thing I'm going to show you guys tonight, the ground is almost more important than the input. And more I've been studying a few people out there that have told me this, and it turns out to be actually pretty valid. Just dropped all this stuff here. Dropped all my stuff on the ground. All right, so it's going to go from plasma ball, radiate onto my panel, and then from my panel, it's going to go through my high voltage homemade capacitor, and from the capacitor, it's going to go to this power lead here. To stretch that out, and then here it's going to go to my positive of my light. This is just kind of a quick mock-up. I want to see what's actually happening here. Okay, so I got that, all right. And then get that hooked up, that's there. And I hope everybody can see everything okay. Any questions, comments, shoot. Ground. Now, I did a test with this thing last night. Actually, I didn't mention to anybody yet. I didn't even make a video last night. I was so into my work here. I was able to get in my setup 163 volts off this. That's actually quite impressive. 163 volts. And I did a couple experiments where I actually grounded this. I didn't actually have to ground it, and it still lit up. And I'll put the light here so everybody can see it. I'm trying to put everything in a way that everybody can see what I'm doing. Okay, there's the light. All right, so let me just turn it on. This thing's funny. So if I can get this light up. got some light there. Thank you very much. Okay, now if I direct it out. Okay, get a bit of light going there. Alright, so that's off the spring. Okay, I am getting some power here. I don't know if you can see that, but it is lit. Let's do this. Closer here. Yep, it's lighting up. Okay. Let's go. Another. Good. I'm gonna grab another light. Bear with me for a minute. I'm gonna do this light here because it's more noticeable. This one's actually an 8-watt bulb. This one lights up. So this one's actually lit. So we've got my capacitor. It's not that bright. Okay, if I get a little closer. Okay, I can't touch it because then I ground it. Oh, I see. Okay. Try something here. Okay, shut that off. I'm going to attach. Instead of on the spring, I'm now going to attach it to. I'm actually going to attach it to the copper plate. I'm going to see if these. Okay, so attach that there like that. Let's try it again. It seems to be better. Got more power. Try to get everything in the picture here so that everybody can see it. Okay, so it seems to be very directional. I'm not sure hooking this right up to a ground. Just watch out, Angela. Okay, that ground seems to work really good. So I'll show you when I shut it off. That's with it off, and now that's with it on. So yeah, it seems to be charging pretty good. I'm getting a pretty good response out of it. It's not bad at all. It's actually pretty good. Let me try the other light. One thing I did notice with this system, if you use those little neon bulbs, they produce a lot of power. See, now this thing's going good too now. So I think it's surface area that's really a big deal. The more surface area that you have exposed to it is where you get a lot of power. So, and I also found out too, I got a cup of water yesterday. I put the ground in the cup of water, and then I stuck my finger in the water and the light came on. So water is a very good conductor of this. Actually, yeah, it worked really good. A lot better than I thought it would. Yeah, so, yeah, if you guys just joined us, yesterday I made a homemade capacitor. So I charged this thing up with 11,000 volts yesterday and it held. So, yeah, it works pretty good. Alright, now what I want to do is I want to try maybe standing it up. I have to get, bear with me for a second here. Got this jar here to hold it. That's 8 watts. 8 watts, and yesterday I did a test setup. Yesterday I was getting 163 volts. I was peaking 163 volts out of this thing, so that's actually really good. So here, capacitor there. Yeah, look at that. It's pretty bright. So there's good. Oh, and the other thing too is with the setup that I had yesterday, I can charge super capacitors. And they, as you know, supercaps take a lot of power. They take a lot of power to get power in, to charge one of those damn things. They're not the easiest things to charge. Supercaps, batteries are totally different, but supercaps, yeah, they take a lot of amperage. So. Yeah, this is working pretty good. This is working pretty good. Now what I'm going to do is I'm going to pull off one of these guys. See if there's a difference. Let's see if there's any difference. Yeah, it seems like there is a bit of a difference. You can't really tell, but from my standpoint, yeah, there is a bit of a difference. So the second I put this back on. Now, the thing is, too, I'm grounding this thing right now. It should be going off. And it's not. That's weird. Usually when I ground it with my hand, it goes off. So with these things, ground is almost more important than your input. If you got a good ground on it, setup, then yeah, she works pretty good. See, this is 8 watts. And this thing here is probably putting out plasma bulb maybe about 2,000 volts. If you get a good gap going on it. Let me bring this a little bit closer. See, that was weird. I was touching that other one. Yeah, see, when I put the 4.5 watt bulb and I touch this plate, it doesn't go out. There, that's really bright now. That's kind of cool. And I got some good brightness going on this. It's kind of interesting. Maybe I'm going to touch it for a minute. Okay, these are actually touching now. And she's like, well, you can see how bright it is. Just bring it just away a little bit. And I still got a lot of power. Yeah, it's going pretty good. What else can I do? Let's see what we got here. Okay. So got that. It's attached really well. Here's the homemade okay. It's really bright. Let me try that. I'm going to change the position of these. I'm going to put them right on the end. Oops. So I got them set up way far apart now. That's how I got it like this. Got some good light there now. That's putting a real decent amount of power out. So it seems like these collectors on springs seem to conduct a lot of the power by the looks of it, from what I'm seeing. The springs are capturing that radiant energy a lot better. So not just the flat plate works really good, but yeah, using springs on a piece of even on aluminum. I bet you this would even work on aluminum. Now the thing is too, when I do my other experiments with these plates, I'm putting them about maybe a quarter of an inch away from the plasma ball. Well, this thing now is about 3 inches away, and the springs is what's picking up that power. And I'm getting actually, if not almost even a better result. And I only got my homemade Supercap hooked up to this, the homemade capacitor. So it seems like the springs really collect the power, the radiant energy. Like, look at that, how bright that is. And I could not get that bright with the plate 3 inches away. I couldn't do it. Now that I got the spring hooked up and the springs are collecting the power, now they're also in a spiral in the spring. So I don't know if that has anything to do with it, the way it's collecting the power. Actually, you know what I want to try is just doing one spring without the plate. Let's do that. I want to try it without the spring, or without the plate. So we are going to do this. Take the one spring off, and I'm just going to hook it right up to the darn wire. No capacitor. Oh, it's starting to light a bit. Okay, let's try it with a smaller plate. 4 watt in. See, it's already collecting power. The second I put it on the plate, but if I just do the spring on its own, no capacitor hook up to it, it's still collecting power. See, just having one wire. It's literally one wire to the bulb and one wire to the ground. So I'm collecting it just with a darn spring. Now, if I had the capacitor hooked up to this, I'd probably get even a better result. Let's try that. Okay, so I'm going to detach this capacitor and take there. I'm going to hook up this. So I'm going to try to connect this somehow. I'm going to connect one wire of the capacitor to the spring, and then from there I'm going to connect the other end to the power wire. Alright. And I'm just going to dangle it close to it. Try not to touch it. Okay, let's try this. Yeah, see, even with that, I'm getting a decent power. Like, it doesn't take much as long as you got some connection. Like, I'm just using literally one spring connected to my homemade capacitor. Touch the spring from the spring, go into the one lead, and it goes right to the light. And I'm still lighting up. So you can see how good the connection is. Now the plate just helps the whole situation. I got these two copper. The wires are 1 inch diameter by 3 inches tall. Just regular solid copper wire. And yeah, so you can. I just put it around a spool, paper spool, and round it and made a nice coil out of it. And yeah, so, and I'm just holding this with tape. It's just a quick mock-up, just to, demonstrate what you can actually do. And, everything here is homemade. Like, I'm not, like, spending huge bucks here, You can buy these copper plates at, I think I even seen them at Home Depot. You can buy these copper plates. And I'm going to touch the capacitor back onto this. Hook this back up. So we got some capacitance. So I think with radiant energy, it's not just a collector, it's a capacitor. So you can, I even did it in yesterday's experiment where I got copper plate, I put a plastic sheet in the middle, and I put the aluminum on top, and I put one electrode on the back, and then exposed the side right up to the thing, and it actually acted like a capacitor. So these, when you got the radiant energy, the static or whatever you want to call it coming off here, it will go through 3 plates. You might not think it would, but it did. But these ones here are like, they're probably about 3 millimeters thick, 2 millimeters thick. And then a plastic sheet, and then another aluminum sheet on top of that. And so it's going through 4 millimeters of metal with a dielectric in the middle. And this thing can radiate power through those 2 plates and the dielectric and actually get power out the other side, which I think is pretty amazing all on its own, because it's able to actually travel through a dielectric like that. It's pretty amazing. And it's, you're just dealing with static electricity here. We're not dealing with hundreds of thousands of volts. I'm dealing with, this thing might put out 2 kVA, but don't forget, it's in a vacuum. This isn't a vacuum situation. You got plasma, and it's a plasma ball. So you're dealing with new physics now when you have a plasma ball. All right, so I just got this here. Let me try to angle it better so you can see what I'm actually doing. All right, if you guys can see that. So I got the springs about 1/2 inch away, and now this plate, normally I would have about 1/2 inch away from the ball. So now I got this plate a good 5 inches away. Normally, I would have this plate about ½ inch away or closer, quarter inch. So now, I got it hooked up, and I'll shut the light off here, and you can watch the light come on. Boom, instantaneous. So yeah, if you like what you see, guys, give me a thumbs up, that'd be great. And also my videos there. If you go in the description of my videos, I also have my PayPal donate. So if you guys want to chip me a buck, enough to buy me a coffee, that'd be awesome. Yeah. So yeah, I'm working on plasma ball stuff. It still fascinates. Oh, actually, I want to show you guys something. I'll be right back. I'm still live. So I went to Indigo today and I bought a book on Tesla. So that's what I'm reading right now. And it's got some pretty good stuff, actually. I picked it up at Indigo. It's by W. Bernard Carlson. And yeah, so I'm reading the book now. It's got some of his patent stuff in there, give some history on them. And yeah, I'm just doing, I'm going to start myself a library now and, start collecting books and stuff on Tesla. And it's not that easy to find stuff on him. Like, I went to Indigo and looked in the computer, everything was online. It's like, you gotta be kidding me. I came all this way to the bookstore and I can't even get a book on it. So I started walking down the aisle and for some reason I stopped and I looked behind me and so I looked to the side and there's this book sitting on the shelf. There was actually two books, two different books. I grabbed this one here. It's a little bigger than the other one. And yeah, it was weird. I just started walking down the aisle randomly. I'm kind of mad that they didn't have anything in stock. So I'm walking and all of a sudden, yeah, I just stopped. And I'm like, I looked to my side and this thing's staring me right in the face. So go figure. Yeah, so I got that. Yeah, so kind of a funny story there. So this thing's going pretty good. I like it. It seems to be a pretty good collector. I think what's happening is the radiant energy coming off the ball. The second it comes off the ball, it looks for ground. It looks for a place to ground itself. And actually, if I put my finger close enough to it, I can see little arcs coming off my finger. Yeah. So it's producing quite a bit of power. This 4 watts. I'll put the 8-watt bulb in there just to kind of show you some output. Now I did test with this last night. I was getting 163 volts out of it. So it's pretty good. There we go, see? Lit up right away. And I think this capacitor really helped, this homemade capacitor I made. So, yeah. Yeah, it's working pretty good. Yeah, so what else am I going to do here? I'm going to try some other stuff. What I'm going to do, I'm going to grab one more plate. Got another aluminum plate here. Now this side here on this copper plate, it's a plastic. This was actually for a PCB. So I'm going to put this plate behind it. I'm going to see if it makes any difference. I'm curious. So I got a plate on another plate and I got a bit of a dielectric plastic in between them. That seemed to work pretty good too. Yeah, not bad. Actually, I'm going to detach my capacitor, and now I'm going to attach to the, so the power's coming through, it's hitting the copper plate. Now on the other side of the copper plate, it's not conductive, so I got a dielectric there. Now I'm going to attach it to the plate on the back. Now watch. Now when I did that, I saw a spark. So it seems like you have to make a capacitor pickup plate that actually gives you, it's acting like a capacitance type collector. See, that thing's lit up pretty good. And when I hooked it up, I saw a spark. Yeah, I'm getting sparks off this. This aluminum plate's actually sparking. I don't know if you guys can see it. I'll try to do it. I don't know if you'll see it. Let me try to move up the camera. I don't want to get the camera too close on my phone, otherwise I might fry it. I don't know if you'll be able to see it. But you might actually see a spark going there. I can see it from my view. I don't know if you guys can see it. There's actually a spark. Yeah, give me a thumbs up if you like what you're seeing. Yeah, she's producing power. So this thing is now running like a capacitor itself. Look at the power I'm getting out of it. And it's simple. It's just off a plasma ball. Like, who would think you could get that much power that you can light up 8 watts? That's pretty amazing, actually, when you think about it. Now, I said earlier in the stream tonight that the ground is almost more important than the input. So, you know, you got potential, you got a capacitance plate, which Tesla talks about all the time. So when you're taking radiant energy or high voltage, it has to go to a condenser. And this is it right here. This is the condenser. Now, from the condenser, I can do whatever I want with it. So now I can hook this up to a full-wave bridge rectifier, and I can charge capacitors. Speaking of which, I'm going to get that set up right now, and I want to charge a capacitor. So let's do that. So I have, I'm just going to shut this off for a minute. So I got my full wave bridge rectifier. These are high voltage diodes. So you have to use high voltage diodes when you're working with any of this stuff. Regular diodes, they will fry. They'll work for a few minutes, but they eventually will die. So you got to get, these ones are rated at 15 kVA. So if you're using high voltage static or plasma, or if you're using the Don Smith generator, high voltage diodes. And here I'll show you. So I got it on the board there. It's backwards, but you can see the arrangement. And that's the arrangement of my diodes. All right, so I'm going to hook this up now, and I'm going to try charging the Supercap bank. So I might have to rearrange some of the stuff. I'm going to put the camera a little further away, so I got some room. Okay, so this, okay, it's going to go to power. Okay, I'm going to detach this. Okay, this is going to be, okay, so I got AC positive here. This is AC negative. So it doesn't go flying off the table. Okay, move this a little bit. Get that up there. And I'm gonna get 1 minute. So I'll be right back. clips. So I'm hooking up a capacitor. I'm going to start charging caps here. So here's my capacitor banks, 90 farad, 12 volts. And I'm going to hook this guy up. As you can see right now, the light's not flashing on it. So that means it's discharged. I'm going to hook it up to here. DC positive. There. And this up here. Now, the other thing too is when you're charging capacitors, you have to do a separate ground. See, I got the ground wire on this. This has to go to an earth ground. If you don't put it on an earth ground, this cap bank will take forever to charge. And if Paul's watching this, I don't know if Paul Inventor 3 is watching. So he was trying to charge batteries tonight. Oh, go check out Paul's website, YouTube channel, Inventor 3. He's awesome. He does all this radiant energy stuff and power collection. And he's based out of Chicago, as far as I know. And he's doing some really good work out there. So go check out Paul, Inventor 3. You can do a YouTube search on him. He's awesome. So yeah, so Paul's watching. I don't know if he's watching or not, but I'm gonna get a ground wire coming off of the Supercap, and that's gonna go directly to my ground. Now you can also hook it up to the same ground as your earth ground. That's what the idea is. So I'm hooking up this right directly to earth ground. All right. So there's a lot of grounds in this. You got more grounds you use, the better. So I got the light here. I don't know if it's going to show up. I'm going to turn this on, and maybe, just maybe, it'll start charging. Sometimes things don't always work. Oh, yeah, it's charging. All right, you're going to see it's going to start coming on. You'll see this green light start to flash. So we'll let it run for a few minutes there. I'm just going to top up my coffee here. Yep, it's coming on. It's charging. That light's starting to come on. You can't really see it too well. Oh, shoot. My breath came off. There we go. Yes, he's going. So we'll have to wait a few minutes. This thing's like dead, so it'll take a little bit of time. Let's get this thing set just a little bit closer. Oops. Please stay. Oh shoot, maybe I should have did. Okay, I'm going to attach this capacitor to it. Oh yeah. Yeah, it's going. All right, I'm just going to let that go for a few minutes there. If you like what you see here, give me a thumbs up. And in my videos, descriptions, I got my PayPal. If you just want to chip me a buck, that's awesome. If you like what you're seeing tonight, try to get a little better view here. So this Supercap bank is charging. The light's starting to come on. It'll take a few minutes, so I'll just kind of let it run. I can see it now. It's not showing up for you guys, so I'm going to let this run for a few minutes and just let it go. And yeah, she's going pretty good. Pretty soon it'll be bright and you'll see it just blinking away. So this is 90 farads. It's a lot. It'll give you a good jolt, and it'll run a DC electric motor no problem. 90 farads, quite a bit of power. This setup I have here, It's set for 12 volts. So yeah, it's working pretty good. Just kind of clean this area up a little bit. Yeah, the second you put the earth ground to the load that you're trying to charge. So if you're trying to charge a cap bank, you have to have two grounds, one from the system and another earth ground to earth directly, not using through your system. A separate earth ground altogether makes all the difference in the power flow, because believe it or not, some of the electrons it's negative energy. It's coming back into the system. So it's almost like it's going like this. You got power coming in this end, and then you got the negative energy electrons coming this way, and they come to the middle. And they meet right at the Supercap bank, because I don't know if you know Supercaps, it takes a lot of amperage to charge one of these guys. If I put this on my DC power supply, it'll pull 3-4 amps easy to charge this. Okay, I'm doing this with a plasma ball, and it's charging. Like, the light's coming on now. I don't know if you guys can see it. Maybe I'll pull it closer. I don't know if you can see the light. Maybe I'll try to hold it up for you. I don't know if you can notice that it's starting to blink, but it's coming on. It's light. It will be a lot brighter. We've got to give it a few minutes, and she'll charge up. So yeah, I've been busy making those homemade capacitors. It's a lot easier than you might think. Yeah. So I'll let this run for a few minutes. Any questions? Shoot me any question, and I'll try to answer it for you. Yeah, Bernie, if you're watching or whatever, give me a shout, please. And I have some stuff I want to talk to you about. Yep, it's charging. It's getting brighter and brighter and brighter. I don't know if you can see it's right there where my finger is. It's still pretty, it's not very bright yet. It's going, it's getting there. But it is charging. Now, every time I'm adjusting this plate, I'm actually getting a bit of a shock. So I think the collector plate for this thing actually has to be a capacitor itself. So bigger the capacitor plate, better. Now, what I'm trying to do is find a plastic ball this is a 6-inch plasma ball. I want to find something that's maybe a 7-inch or slightly larger than a 6-inch. And I want to encapsulate the actual ball itself with another one. And then on the inside, I'll put that aluminum foil tape all on the inside. And then put another aluminum foil on the outside. So you'll have aluminum, but then you'll have the glass or whatever plastic dome that you're using. That's your dielectric. And then you'll put another sheet of that tinfoil tape on the outside, and then you attach your electrode to it, so that becomes actually a capacitor. That's what you want to try to do. That'll actually work amazing. If you can get one that's actually the same shape as the plasma ball, it'll work amazing, because you're going to get maximum coverage of the ball, and you're going to get maximum efficiency, because you're going to collect all that field that's radiating off the plasma. So I don't know if you can see the light now. It's starting to blink. It's more noticeable now. It slows charge, but you know what? You have to realize this is 90 farad. It's a large cap bank. So yeah, sometimes experiments take a while, so but yeah. Now, would it be a really cool experiment? Maybe someday I might actually try it. Is go near a place where You can see high voltage power lines, you know, on the big poles there. If you have any in your area, you can make a capacitor plate like this, put it on the ground or put it on a tripod and face it upwards towards those power lines. Get a good, like maybe a spike or like a nail that's maybe 5-6 inches long. Hammer the sucker into the ground, hook up the ground to it, and you'll be able to light up light bulbs. There's so much RF coming off power, like radiant energy coming off those power lines. There's 46,000 volts going through that. And I bet you any money if you were to do an experiment like that, you'd be lighting light bulbs. Easy. Can you just take the ball off the plasma ball? Okay, see, you don't want to do that because you got the gas in there. The gas is what's creating the plasma. The second I take the ball off there, you lose the effect. Now you just basically have a Tesla coil. So it's basically a Tesla coil in the middle, and then you got a vacuum sealed ball with argon gas or whatever gas that they mix in there. And that's what's creating the plasma. As soon as you remove that gas from the ball, that's it. You've lost the plasma. You won't get that arcing. And you want that arcing because that's what's creating the static field. So, good question, but yeah, you need that sealed ball around the plasma, or sorry, around the Tesla coil. That's what creates the the good, really good looking. So those plasma sparks, no gas in there, you won't see that. It has to have that vacuum. That vacuum is what creates all the the arcing, right? And when you ground it, it follows you. That's why I don't want to get my camera or my phone too close to this thing because it can damage it if you get it too close. But one other thing that I noticed since I've been doing this experiment, and even though there is no arcing or sparking going on, I'm starting to smell a bit of ozone. This thing's actually creating ozone. So, and if you notice, you have to have the plasma gas. You have to have that gas. Without the gas, you got nothing. Okay, so I don't know if you guys can see it, but the light's blinking now. Cool, eh? So that's 90 farad it's charging. So it's working, it's charging it really, really good. So now I know how to extract power off a plasma ball. You gotta make it as a capacitor. So even if you were to make like say a box and you put the plasma ball in the box and then you put all your plates all the way around and you do say 3 layers or even 2 layers, you go metal plate, you could use the aluminum sheet, shiny the better, more shiny it is the better. That's what Tesla was saying. So you put aluminum plate, put a plastic sheet, dielectric. You can get those plastic sheets from Staples, 8.5 by 11. Put that in the middle and put another aluminum sheet behind it, and now it's a capacitor. And you do that all the way around, 4 of them. And then all you do is connect one lead off of each one, connect them all together as one. So now you got all the way around the plasma ball. Dump it into a capacitor, light a light bulb like this, whatever you want to do. And like the experiments I did last night, I was actually measuring the power. I was getting about 163 volts coming off it. And, this thing's not taking very much to run it. I think it's like 8 watts to run this, right? And it produces about 2 kVA. So, yeah, see, light's on. She's blinking. She's charging. So yeah, I like this. This is cool. Anybody else have questions? else can I do here? Just thinking. I'll just let this continue to charge. Yep, now it's blinking pretty good now. Like it's really charged. So the key to charging capacitors or anything, you got to have a second ground going to earth. The second you do that, you're going to now pull electrons, the negative energy, from the ground to your setup. And you got power on the front end that's drawing energy to the center. So you got this power coming from both sides. And because of that, you're able to charge this 90 farad, by the way. So, you know, this thing will just keep going and going and going. It's probably already got about 2.5 volts already in it. So when this thing's at full 12 volts, this thing's bright. It's called blue, you know, like a beacon. So yeah, I can just let this go for quite a while and just charge it up, and then you can dump it into whatever. You can run a light, or you can run a small DC electric motor off it. Yeah, you can do whatever you want. So I'm just gonna let this continue to charge. Let's see what else I got here. This would be interesting. I'm going to try hooking up this coil. I found this coil. So I'm going to hook this coil up where the homemade capacitor. I'm going to hook it up to this in series. Yeah, let's do that. There. There. That's interesting. That's actually a good idea, I think. This light's going pretty good now. See? Yeah, if you like what you see, give me a thumbs up. I'm charging Supercap banks with a plasma ball. So I got a collector plate here I designed. It's like a capacitor, and I've got a couple springs in the middle. Oh yeah, outdoor antenna, yeah, for sure. I'd like to do some experiments outdoor. But right now, I'm in the middle of winter, and it's like -20 outside. So for me to go outside, right, and it's also a windstorm right now, so not really a great idea. I'll have to wait till the spring. But yeah, I'll start doing some experiments outside with this stuff and see what I can actually accomplish out there. Yeah, this cat bank's really charging now. Wow. It's really going good. So I added another copper little inductor here. So seems to be kind of helping a bit. It's probably got about 2 or 3 volts in it already. and it had no power at all when I started. It was dead. So yeah, it's pretty cool. Let me show you my setup there. So this thing will keep charging and charging and charging. See, high voltage power lines, they would probably be emitting a lot of dirty energy coming off there. And they could have a setup like this that would actually collect that energy off the power. And you wouldn't pay for it, it'd be free. So, yeah, this thing's charging really good now. Wow, I'm impressed. It's really getting bright. Yeah, get them on Amazon. They're like $50 US. This one's a 6-inch. Yeah, you can play around with this thing all day long, and you can learn some cool stuff. But yeah, make your homemade capacitor. This seems to be really helping. Really, really, really helping. So the more you can build like 3 of these things, hook them up in series, hook it up to a plate like this, make it like a 3-layer. Get the springs on the end, then you get copper, then put a plastic dielectric in the middle, and then put an aluminum plate on the other side, and then connect to that, and wow. You'll probably pick up quite a bit of power off it. Like this thing's going pretty good now. Like this thing was totally dead when we started. Now look at it. So it's got at least 2 to 3 volts in there right now. It's not charging fast, but for coming off of this, wow. I think that's pretty good. I could hook up a DC motor to this now and run it. No problem. A small little DC motor, yeah, for sure. What else can I do here? I'm just going to let this charge for a bit. Actually, I'm going to get my voltmeter. Get my voltmeter. I'm curious to see how much power is in this thing. I got 2.17 volts in it right now. And it's climbing 2.18. Yeah. I already got over 2 volts of power in this thing. And the light's pretty bright already. Pretty cool. And she'll keep climbing. Keep going. I could run this thing for an hour and she'll keep going and going and going. It's a good thing I got the chaser light on it, the blinking light, because it's better when you're trying to charge something instead of running a load on it continuously. It's blinking, so it gives it time to actually charge and not just waste all the power off the light. This is just to show me there is power in it and it's running. So. She's running good. Oh, the other thing too is somebody asked me why don't you just connect your plate right to the bulb itself? Okay, when I hold it there, it's arcing, it's shorting out on the ground. Now, if you continue to do that for a long time, what's going to happen? The bulb's going to start heating up in the inside, and you could get a failure, or you could burn out the Tesla coil. So the idea is get as close as possible to the bulb without touching it. If you don't touch it, it will not dead short. Because right now, I'm dead shorting it just by doing this. And you'll also notice you'll smell the ozone, okay? So you want to get your conductor plates as close as possible to it. I'm using the springs to actually collect that radiant power. So you can get the springs just before it touches it. Like I got them about 1/4 of an inch away. I can actually go a little closer if I wanted to. Yeah, that's pretty close. That's less than a 1/4 inch, maybe a 1/16 of an inch. And the lights, my Supercaps are charging. So yeah, when you're building this, ground is like so critical. You gotta have an awesome ground. So I would go out, buy a copper rod, 1 foot, 2 feet long, hammer that sucker right into the ground. That way you've got a good ground. Ground is everything for this system. You got power coming from here, you've got the ground here, you got the negative electrons coming from the ground. You want them to come together. When you come together, you get maximum power output. Now, I can see, I'm using a magneto dielectric, I'm using a Tesla coil, which is inside the plasma ball. I can light a light bulb without using a ground. The second I put a ground, boom, you get full power. But I can just take that loose wire and just hold it in the air. It's an air ground, and the light will still go on. I think I showed that in one of my last videos. So you're dealing with a different type of power. You can't do that with DC, and you can't do it with AC. But this power source, you can. You can light a light bulb with 1 wire. You can have an air ground. So, yeah, this thing's really bright now. Whew, cool. Let me do another measurement of the voltage. It was about 2.18 volts. Let's see how much I have now. 2.22 volts. Just going up. Almost 2 1/4 volts in a matter of about 15 minutes, I'd say. It's not bad, but when considering it's a capacitor, it takes a lot of amperage to charge. A lot of amperage. Yeah, that's really cool. I think having mass in the area and being able to capture all of it. Don't forget, I only got one side going here. If I had something go all the way around this thing, like I said, if I had a box and I put these plates inside the box and did this similar arrangement in there, I'd get quite a bit of power. I'd be harnessing as much of that flux that's coming off there, the radiant energy coming off it. And that's working good. I gotta top up my coffee again. So what I'm going to do is, I think I'm going to take a break. I'm going to do another live stream later. And yeah, I'm just going to take a break here. I'm going to stop the stream and then I'll start another one a little bit later. It's still pretty early, so yeah, I'm going to let this go for a little bit, let it charge. Maybe get it up to about 3 volts. And yeah, I've already been going 1 hour and 17 minutes. So yeah, thanks for tuning in. Give me a thumbs up if you like the video. And yeah, I'll be going live again later on tonight.